In this video, we're going to discuss parallel and perpendicular lines. So two lines are parallel if they have the same slope. And remember that slope measures steepness, so these lines essentially have the same steepness. So they might both have the same positive slope, in which case they're increasing at the same rate from left to right. They might both have the same negative slope, decreasing at the same rate. So since they're parallel, they're never going to intersect because they're increasing at the same rate or decreasing at the same rate. They might both be horizontal lines, in which case they would both have a slope of 0. Or they might be both vertical lines, in which case both of them would have a slope that's undefined. Two lines are perpendicular if their product of their slopes is -1. So product meaning if we multiply both slopes of the lines together, we get -1, which already tells us that one of them is positive and one of them is negative. Because if we multiplied two positive slopes together, we'd get a positive number. If we multiplied two negative slopes together, we would get a negative number. So in order for the product of the slopes to be negative, one has to be positive slope and one has to be negative slope. But it's more specific than that. We don't just multiply them and get any negative number. We get specifically -1. And if you think about multiplying two numbers together and getting a result of +1, that would suggest that the numbers are reciprocals. For example, 2 times 1/2 is 1. 4/3 times 3/4 is 1. If you multiply reciprocals, you get 1. So essentially, the slopes are almost reciprocals, except one is positive and one is negative. So sometimes we say that the slopes of perpendicular lines are opposite reciprocals. The word opposite meaning they have opposite signs. One's positive and one's negative. Opposite signs, one's positive, one's negative, and then the number part, like if you ignore the signs, those are reciprocals. And so what happens then is, here's an example of a line with a positive slope because it's increasing from left to right. And then I'm going to draw a line with negative slope, so it's going to be decreasing from left to right. And if those slopes are opposite reciprocals, then what happens is these two lines are perpendicular. In other words, they meet at a right angle. So here we have an equation of a line, and we want to write an equation of a line that's parallel to that one. And we want this other line to pass through the point 3, -5. So our point slope form is going to be pretty helpful here because we know a point that we want the line to pass through, and we know it needs to be parallel to this one, which means it needs to have the same slope. So we need to start by finding the slope of this line. Which we can do by rewriting this in slope-intercept form. So y equals mx plus b. So we might want to subtract the x and add the 8 to both sides. And then to get y by itself, we need to divide both sides by 4. And so since there's multiple terms on the right, we need to divide each term by 4. All right, so 8 over 4 is 2. Now what's going on here? This is negative x over 4. That's the same as negative 1/4 times x, because it's x over 1, and so you'd have a negative 1 times x in the numerator and a 4 times 1 in the denominator, which is the same thing. So the slope here is negative 1/4. All right, so we want to write an equation of a line that's parallel to this one, which means it needs to also have a slope of negative 1/4, and it needs to pass through the point 3, -5. So using our point slope form, we have y minus y1 equals m times x minus x1. And we can write the left side as y plus 5, and it's still considered point slope form. So part A here was asking for point slope form. That's what we have here. Part B wants this equation of the same line but in slope intercept form now. And so all we need to do for that is take this form and rewrite it in slope intercept form. So slope intercept form is y equals mx plus b, which doesn't have parentheses. So the first thing we need to do is distribute that negative 1/4 on the right side. So we'll have negative 1/4 x, and then we'll have a negative times a negative. So a positive there, and it's 1 over 4 times 3 over 1. So that'll give us 3 over 4. And then the only thing we need to do yet is get y by itself. So we're going to subtract 5 from both sides. So we're doing 3/4 minus 5. So you can get a common denominator there if you like. So that'll be 3/4 minus 20 over 4, because 20 divided by 4 is 5. And that'll give us negative 17 over 4. So that would be the slope intercept form. All right, this one's very similar, except now we want a line that is perpendicular to the given line. So here we have a line that's given. It's already in slope intercept form this time, which is kind of nice. So we know that the slope of that line is 2, or 2 over 1. And so the line that's perpendicular to that would have then a slope that's negative. One's increasing, one's decreasing, and reciprocal of 2 is 1/2. Remember, the slopes should multiply to be -1. So if you do 2 times negative 1/2, you do get -1. All right, and then this perpendicular line should also go through the point -2, -6. So using our point slope form, we'd have y minus -6 equals -1/2 times x minus -2. Which we can write as y plus 6 equals negative 1/2 times x plus 2. So that's what we wanted for part A. And then part B, we just want the slope-intercept form of this same line, so it's just a matter of rewriting it as y equals mx plus b. So we'll want to distribute on the right side first. So we'll have negative 1/2 x. Then we have a negative times a positive, and we have a half times 2, so that's going to be negative 1. And then we just want to get y by itself then, so that it's in slope-intercept form. So subtract 6. And we have y equals negative 1/2 x minus 7.